simplified with radicals, they are going to have actual equations to solve. So the first one that we're looking at here says square root of 3x plus 4 is equal to 8. Square root of 3x plus 4 is equal to 8. And our directions say to solve. Okay. We're going to have a small checklist that we go through to solve these. And the first one is going to be, is the radical isolated? Is the radical all by itself? In Algebra 1 we talked about isolating the variables. So now we're talking about isolating the radicals. What that means is there any extra junk that's being multiplied by that square root piece or that's being added or subtracted to that square root piece. In this case there's not, because everything on the left is underneath the radical, right? That's what we're talking about. So it's all by itself, so we're good. Check. The radical is isolated. Step 2 then will be to get rid of the radical. So we just got to figure out what undoes a square root. Squaring it. So that's simple. So we're going to square it. In order for that to be legal, like Rachel said, we got to square the whole thing. Okay? So here the squared and the square root cancel each other out. You just got 3x plus 4. Here 8 squared is 64. So now you've made an easy two-step middle school equation to solve. What will our first step here be? Subtract your 4. Aaron said we get 3x is 60. Last step. Good job, Keston. So x is 20. Now, when we're dealing with radicals, there's limits to our answers because you can't have a negative underneath the radical, all that kind of stuff. So this is a day when we're going to have to make sure we check our answers. So I'm going to do that mentally with you right now. Take that 20 back to the original problem and plug it in for the x. That says 3 times 20, which will be 60. Plus 4 is 64. Square root of 64 is 8. So that says 8 equals 8, which is a true statement. So our answer was correct. If we get a false statement, our answer is wrong, there'll be no solutions. Okay? Pretty easy, pretty simple. Unless I add a step, just keep stepping it up till we get to the biggest one. We got the square root of 5q minus 1. And then a plus 3 is equal to 0. Square root of 5q minus 1 plus 3 is equal to 0. Alright, so is the radical isolated there? Is it all by itself? No is correct. Good job, because there's an extra plus 3 stuck out on the end. So that's going to be our first deal here, is to get rid of that plus 3. How do you do that? Subtract 3. So I got square root of 5q minus 1 is equal to negative 3. Okay, now we're to where the last problem was. We got the radical all by itself, so we're going to get rid of it. How do you get rid of a square root? Square it now. Could be a cube root, could be a fourth root. So whatever root it is what power cancels that out, right? Okay, so square cancels the square root out. 5q minus 1 equals negative 3 squared. That's negative 3 times negative 3, which is a positive 9. Your two-step middle school equation. Add 1. So that'll get us 5q is 10. And then divide. So that says q is 2. Okay, let's check it out. But take it back to the original problem. 5 times 2 is 10. 10 minus 1 is 9. You with me underneath the radical? Square root of 9 is 3. 3 plus 3 is 6. So it says 6 equals 0. Whoa, 6 does not equal 0. Q equals 2 then made it a false statement, so this thing has no solution. Yikes. Everybody remember?
You don't see that at the beginning?
Yeah, you could. Some people could.
Wait, where does the 6 come in from?
When I plugged the 2 back in for the Q spot to check it, that's what it got me. because this ended up being 3, so you had 3 plus 3. $1,000,000 question. What's that called? What's Q equals 2? What's the 2 called? When we did all that good work and we got an answer, but we plugged it back in and it didn't work. It's a humongo word that starts with an E. So what's the $1,000,000 question? Extraneous solution. Extraneous. We've said it maybe once or twice. Extraneous.
Sorry.
Yes.
I need Rachel Lewis to check out.
Yes.
Thank you.
Alright, add a step. You ready? I got square root of 5 minus, no, let's not do that. Square root of 4 minus x is equal to x plus 2. Alright, so obvious step that we've added is this has got a binomial on the right side. Okay, that's what we're going to have to deal with here in just a second. Go ahead on the left. Is the radical isolated? Is there any extra junk to get rid of? No, you're right, Michael. It's good and isolated. So let's just get rid of the radical. Undo the square root by squaring everything. So that'll give us 4 minus x. Now here's where you got to hit the brakes. This squared does not mean square the x and square the 2. It means you square the whole binomial. Very good. So you've got to take that x plus 2 and write it twice. Okay, so that'll get us x squared. Here's a 2x and a 2x, which is a 4x. And then there's a 4. Okay, what type of equation do we have here now since that's a squared? What's that called? It is a polynomial, yeah. But the last problems that we got have been linear. This is squared. It's non-linear, but more specific, it's a quadratic. Right? When our highest power is 2, we're a quadratic. All right, when we solve quadratics, we set them equal to 0. So I got to move that 4 and that negative x over. So I'm going to subtract the 4 from itself and its buddy on the other side. I'm going to add the x to itself and its buddy on the other side. So it's going to give me x squared plus 5x equals zilch, right? Because 4 and negative 4 goes away. Okay. If that had been a trinomial there, x squared plus 5x plus 6, something along those lines, we would try to factor it. But this is just a binomial, and it's easy to factor that one because it has a GCF of x. Okay, so taking x out of that, that'll leave you with x plus 5 equals 0. Just factor the x out, right? Now you've got 2 factors there set on both equal to 0. X equals 0. That's for that first factor that I underlined. Then my other one, x plus 5 equals 0, gets you negative 5. Okay? What that means now is we've got 2 potential answers. They could both work, only one of them could work, or none of them could work. So we got to plug them both in and go check it out. So I'm going to take the 0 up there first, back to the original problem. Plug the 0 in for that x. 4 minus 0 is 4. Square root of 4 is 2. So that gets me 2 on the left side. On the right, 0 plus 2 is 2. So 2 equals 2. That's good, right? So 0 is a good answer. I'll circle that thing. Negative 5. 4 minus negative 5, and the original problem is 9. Square root of 9 is 3. On the right side, negative 5 plus 2 is negative 3. So you got 3 equals negative 3. Is that good? Nope. So that one's out, so we only had 0. Ooh, oh, I forgot to change all of them over the prism. Alright, this next one that we're going to look at adds a wrinkle, but it's not any more difficult yet. square root of x squared minus 4x plus 9 is equal to x minus 1. Okay, so new thing that's on this one is that's trinomial under the radical. X squared minus 4x plus 9. We got 3 terms underneath there. Still got the 2 terms, the binomial on the right side like the last problem. But still got to check, is the radical all by itself? Is it isolated?
No.
Look again. Yes, there's nothing stuck on that left side that's not underneath the radical, so it's all by itself. So we're going to get rid of that square root by squaring everything. So that'll just leave me with x squared minus 4x plus 9. Same as last problem. We have to write x minus 1 twice and FOIL it. Okay. I would bet y'all can probably do that without writing it, but I'll go ahead for in case I need to. X squared minus x and minus x is minus 2x plus 1. I told y'all the shortcut on that before. You square the first one, square the last one. That's where the x squared and the 1 came from. Then you multiply them and double it. So negative 1x times 2 is negative 2x. Okay, good. We're going to start setting it equal to 0. So Keston's starting with subtracting the 1. So subtract the 1 from itself and its buddy on the other side. What else can we do while we're doing that?
Subtract or add 2x.
Add 2x to itself and its buddy on the other side. And then one more.
Can't you cancel out the x squared?
Good job. Subtract x squared from itself and on the other side. And Dustin's right. That cancels them out. Because x squared minus x squared is nothing. Negative 4x plus 2x is negative 2. That's good, Keston. 9 and negative 1. Okay, this is an easy one to solve now.
Will we do it again?
No, we just need to solve that for x. Now that's linear now. So I need to get the x all by itself. Yeah, not yet. Good, let's subtract that 8 first. You're way overthinking.
No, that's what I meant when I said do you do it again.
Oh, I'm sorry. Yes, you were right. Negative 2x is negative 8. Now, what if somebody wanted to have added the 2x? Would that have been okay? Instead of we subtracted 8, could we have added 2x? Yeah, you could have. So Caitlin's right on that. Divide by negative 2. And x is 4. Alright, once you get that caught up, let's go up to the top and see if it works. Got a little bit more work to do to check it out now. Let me get a dry erase so I can scribble a little bit. We got 4 squared, so that's 16. Minus 4 times 4, so that's 16 minus 16 is 0. Plus 9 is 3. Square root of 3 is 3. 4 minus 1 is 3. Oh, like I really needed a dry erase one for that. I thought I was going to write a bunch more. So 3 does equal 3. So that's true. So that's it. Alright. That one, it just added the trinomial on the left. Didn't really get any harder. This next one that we're going to look at is the hardest kind of the day. So we'll get this one knocked out, then we'll close it off with an easy one after that. Got what you need on that one? Alright, I've got square root of 5x plus 6 plus square root of 3x plus 4 is equal to 2. Alright, obvious dilemma to you is we've got 2 radicals. Okay, so you're going to say, well, yeah, the radicals are isolated. They're all by themselves on the left. But if there's more than one of them, that's not isolated. It's like you're saying you're all alone on a desert island and there's somebody else there. That's not how that works. So it's not isolated because you got a different radical. So we need to get one of those radicals by itself. If that had said plus 7, we would subtract 7. So we're going to do the same thing even though it's a radical. We're going to subtract the square root of 3x plus 4. So we're going to have square root of 5x plus 6 equals 2. minus the square root of 3x plus 4. We just moved that over. Okay, I did write all that. Maybe there it comes. We just moved all that over. Okay, so the radical on the left is isolated now. You're going to be a smart one and say, well, the one on the right's not. You're right. The one on the right is not, but we can only attack one piece at a time. That's part of our superpowers restrictions. We can only attack one thing at a time. So we're attacking the square root of 5x plus 6. So we got it by itself. We're ready to get rid of the square root. So we're going to square everything. So that square cancels that square root out. We got 5x plus 6. All right, here's why this gets a little bit harder. When we square that right side, that's actually a binomial to square. 2 minus 3x plus 4. So I've got to write that twice. 2 minus square root of 3x plus 4. And that's what I'm multiplying. Okay, so that'll give me 4. Here I get minus 2 of those, and here I get minus 2 of those. So that makes minus 4 of those. And then on my last, when I multiply the same thing by itself, if that had been square root of 5 times the square root of 5, it'd be 5, right? The square roots cancel out. So same thing here on my last, the square roots are going to cancel out. Negative times a negative is a positive. Okay, then you can combine those like terms. So that's what's going to be on the right side of our equal sign. So we've got 5x plus 6 is equal to 8 minus 4 square root of 3x plus 4 plus 3x. Alright, so our job, what we were trying to do on that line was isolate get rid of the radical on the left. Well, we did. Good job. Pat yourself on the back. But now we got a radical on the right to get rid of. And it's got a lot of extra junk with it. So we're going to get rid of all that extra junk first. So I'm going to subtract this 8 from itself and its buddy on the other side. I'm going to subtract this 3x from itself and its buddy on the other side. So that's going to give me 2x minus 2 is equal to negative 4 times the square root of 3x plus 4. Alright, now on the right side, that radical is almost isolated, but that doesn't count. We're not playing horseshoes or hand grenades. It's got a negative 4 out in front of it. A negative 4 means negative 4 times all that, so we undo multiplication with division. This is a case where that's going to make this problem a lot harder, because on the left side I've got 2s. If I do 2 divided by 4, I'm dealing with fractions. A half is an easy one. It's not that bad, but they can get scarier. You know, you got like 7/8 and stuff like that over there to mess with. So the easier thing to do, since I've got a 2x, a 2, and a 4, just divide it all by 2 and reduce it. Okay, so that's going to make me have x minus 1 equals negative 2 times the square root of 3x plus 4. Okay, so now we got to get rid of that square root, and I know there's still a negative 2 there, and that's okay. So we're going to square it all. So on the left side, when we square that, that's going to be x minus 1 times x minus 1. So it gets you x squared. Minus x and minus x is minus 2x plus 1. Okay. Now, on the right side, when we square it, first thing we're going to square is that negative 2. This is not a binomial. There's no plus or minus sign between the negative 2 and the radical, so we can just square it. So square that negative 2. That'll get you a 4. Negative 2 times negative 2. Oops. And then square the radical, and it goes away. What do you think we're going to do next?
Distribute.
Not a kid, Mr. Dustin. So I got x squared minus 2x plus 1 equals 12x plus 16. What seems like a good thing to do now?
Subtract 12x.
Kid, Kayla, we got a quadratic, so we're going to set it equal to 0. So I'm going to subtract 12x from itself and its buddy on the other side. I'm going to subtract 16 from itself and its buddy on the other side. Okay, when we do that, that gets me x squared minus 14x minus 15 is equal to 0. Alright, you have done the quadratic formula, and you remember the quadratic formula because you can sing the song, and we can all, x equals negative b plus or minus, you all remember that. We haven't redone that yet in here, we're getting real close to, but we have done a million times as factor. So I'm going to factor this. A times c, what factors of negative 15 add to negative 14?
15 and negative 1.
Other way though. So we'll have x minus 15 and x plus 1. Right? Set both of those equal to 0 and solve. A lot of y'all can skip this step because you know if you got x minus 15 equals 0 that x has to be 15, right? It's just the opposite sign. So you're going to have an x of 15 and negative 1. Okay? Now I've scrolled mine, but you can still see the original problem. I'm going to go back to the original problem and check those. Got that over here on this board for you. Square root of 5 times 15 plus 6 plus the square root of 3 times 15 plus 4 needs to equal 2. 75 plus 6, 81. Square root of 81 is 9. 3 times 15 is 45. Plus 4 is 49. Square root of that's 7. 9 plus 7 does not equal 2. Right? So trash 15. Okay, let's do the negative 1 now. Square root of 5 times negative 1 plus 6 plus the square root of 3 times negative 1 plus 4 needs to equal 2. Negative 5 plus 6 is 1. Square root of 1 is 1. Negative 3 plus 4 is 1. Square root of 1 is 1. 1 plus 1 does equal 2. So our only good answer there is negative 1. There are not a ton of those. Like I said, that's the longest kind of this lesson today. But they're, they're kind of fun. I think that's what I'm going to go home and do tonight after school. Just work some of those. Yeah, you want me to send you some?
No.
Alright, let's go back and look at an easier one just to close it out with. I always like to finish with confidence. This one says cube root. We haven't done anything that's not a square root yet, so we'll throw that in. Cube root 2x plus 7 is equal to the cube root of 3x minus 2. Now there's a reason that this one's a lot easier. What's different in this one than all the rest of them that makes this a lot easier?
Are both of them going to cancel out?
They're both being cube rooted, and there's no extra junk anywhere. So when we cube that whole thing, it cancels both of them out. If one of them had had some extra junk, we'd have to foil it like I did over there on the dry erase board. But there's no extra junk, so don't have to worry about that. They're being cube rooted, so we cube them. Cancels out. 2x plus 7 equals 3x minus 2. Okay, again, that's all because there's no extra junk, so take note on that. Alright, now there's 4 places we could start solving this thing at. Anybody got a preference? Get us started?
Minus 2x.
Minus 2x. Aaron will do that one next. Gets me 7 is x minus 2. Now we got to do what he said. Add the 2. And we get x is 9. Okay, feel pretty good about that. Wasn't any real difficult math to do. Let's go check it out at the top. 2 times 9 is 18. 18 plus 7, 25. Is that right? Cube root of 25. That's not a perfect cube. I don't know what the cube root of 25 is. So I'm just going to leave it as the cube root of 25. Okay, on the right side, 3 times 9 is 27. 27 minus 2 is 25. So I've got the cube root of 25 is equal to the cube root of 25. Even though I don't know what the cube root of 25 is, it's true. It has to equal itself. So 9 worked, and that's your answer. Alright, where we're going next with this stuff is complex numbers, which means we're going to have i's, imaginaries. You know about them. You did them in Algebra 2. Won't be very difficult, but we got to cover that so that then in our next unit we can start attacking quadratic formula again and all that kind of stuff. Okay, everybody good? So we won't get to just write non-real anymore. We'll have to write whatever I. Woohoo, big boy. Alright, that'll be a wrap. Sometimes in Algebra 3 today.